Welcome back to PLS 510, the second half of lecture number 7. This lecture on tall fescue actually is going to span 2 days in the face-to-face class. So the fact that we're going to go and have more than an hour's worth of recording for this lecture is not to make you think that you should have heard this or gotten through it in an hour, or me either. Easily this lecture on tall fescue and its endophyte is easily the most important lecture, you could argue, that we're going to talk about all semester long, because everything we do in a forage setting, in Kentucky anyway, and certainly in the southeast, revolves around tall fescue and managing it. So let's bring intermission to a close, and let's get started with this second half of the tall fescue and its endophyte lecture. And if you'll remember back to the end of lecture or part number 1, we raised the question, and it was raised in class this year, if the symptoms of the toxic endophyte of tall fescue are so dramatic and so bad, how can we even manage to use it as a grass? And I phrased it this way: how do we even have cattle and livestock in Kentucky if this is what we have to deal with? Well, the simple answer is pastures are not monocultures, in spite of the fact that they may be dominantly tall fescue. So let's talk more about that. I want to show you some survey work that we did across 2 different counties, looking at Marion County, that's south and west of Lexington, by about an hour. And we had interns go and make farm visits or pasture walks across a selected number of fields. This is their data. And the next 2 graphs are going to use the same key. So the fescue is the blue pie piece, the light blue. Bluegrass is the next most plentiful, and it's the orange one. Orchard grass, white clover, red clover, and weeds, these same pie pieces. And you can see that fescue, followed by bluegrass, and closely behind that white clover are the dominant species. But we also had a significant amount of weeds. Henry County, in May-June of 2018, these are 9 farms, 2 samplings. A similar pie chart, because tall fescue was the biggest piece, but you can see white clover played a larger role across the average of these 9 farms. And then you've got roughly equal amounts of red clover, orchard grass, and bluegrass. The other in this case would be weeds and bare ground at 5%. Graphically, if you take a look at those Henry County farms for the blue bars, which is the percent fescue in the field, and the percent endophyte present in the fescue in those farms and fields, you can see that the percent endophyte range from about 60 to over 90, but the percent tall fescue peaked out at 50. So what about horses on Kentucky pastures? Remember, we had a set of symptoms that were it would be very concerning if you were trying to raise foals and keep mares pregnant and bring them through to a full pregnancy and delivery, healthy delivery. So what about horses on our Kentucky pastures? Well, if you think about Kentucky and horses, you know that we have a lot of horses in central Kentucky. So similar to the tall fescue story with cattle farms, here is the equine story. This is data across from 25 to 2017 of several farms corrected for weeds and bare soil. So this would be the proportion of bluegrass, fescue, orchard grass, and white clover on these farms across those years. The data that go into this graph come from the Equine Pasture Evaluation Program that has been run here at UK for several years and led currently by Dr. Ray Smith and Krista Lay. So you can see that bluegrass was the dominant species at 40%, followed by fescue at 26%. than orchard grass and white clover at 17 each. Now remember those numbers and those proportions, because we're going to see those graphs, the bars, again in the next slide. These are the averages, but the next slide is going to show you the minimum and maximum for these same 4 species. And what you see, take it, bluegrass with an average of 40% was 70% in one field, in the field that had the greatest amount of bluegrass, and another field it was 0. With fescue, the average was 26. It went from 45 to 0. Orchard grass, 90% almost, down to 2. Average is 17. So more of the fields were closer to 2 than they were to 90. Same thing happened with white clover. You may have some fields that are almost all white clover, 88% for the most in this case, down to 2. So we have a diverse pasture setting in Kentucky horse farms, and a lot of variation even across those. We also looked at, or they also looked at the same pastures for the presence of that endophyte, and this would be the toxic endophyte. On average, it was present in 74% of fields, or it was in the fields were 74% infected, with a max of 97% and a low of 16%. So the take-home message on the occurrence of tall fescue, there's occurrence twice, my apologies, on tall fescue in fields and livestock, and how is it that we have a livestock enterprise in Kentucky with all of this endophyte infected tall fescue, is that if you're a pasture consultant or a farm manager or just somebody concerned about your livestock, know the pasture composition. Walk those fields, learn how to identify species. Don't assume that just because something's true for the state or something's true at your next door neighbor that it's true for you. And test for the presence of the endophyte, and we can also test for the absolute ergovaline content in forages. I want to transition now to the points that will form the latter part of this section of Lecture 7, and that is, how do we manage the toxic endophyte effect? These are the 4 main strategies for managing the toxic endophyte effect. And most of these strategies are cattle-centric, but we'll also have some examples with horses, okay? So, here they are. Renovation with legumes. Number 2, manage to keep it leafy. Number 3, avoid tall fescue completely during the most harmful periods, depending on the livestock species we're grazing, and then replace it. So these are our 4 management options. When we renovate with clover, here are the 4 benefits that we get that make it worthwhile. We get additional yield over the grass alone. We get a real big boost in forage quality, protein, and energy. We also boost some production in summer, which we need pretty badly with our cool season species. So we get a more favorable seasonal pattern of growth with clover addition. And then remember the point early in the course about what we're learning about red clover, isoflavones, and vasodilation. This is the research coming out of the USDA unit here in Lexington, abbreviated FAPRU, which is the Food Animal Production Research Unit. And the next slide will review that for you. I told you a story. The next slide is not that one, but it's to show you the magnitude of the effect of red clover on grazing animals. Now, I will say that this shows that when you add red clover to infected tall fescue, that bumps the gains by about 1 pound per day. You have big changes due to the presence of red clover, but let's talk about why we do. Remember that red clover has a natural growth promoter called biocanon A. It is an isoflavone that is especially high in red clover. This isoflavone is a phytoestrogen that mimics the effect of rumensin and bovatec in the rumen. In other words, it has an effect on the microbial population within the rumen. And remember, we said earlier in the class that rumen and bovatec affect that microbial population in the rumen. And while we call them growth promoters or ionophores, in fact, what they are is antibiotics. They have an antimicrobial effect. The scrutiny of the use of antibiotics in animal agriculture is higher than it has ever had been before, and that's appropriate considering the rise of antibiotic-resistant bacteria that are drastically affecting human health. So the fact that we have a natural growth promoter in biocanon A that gives us the effect of these antimicrobial activity compounds, rumensin and bovatec, is a big plus, and a lot of the credit goes to that research unit here in Lexington, Michael Flythe, and that group, Glenn Aiken, Brittany Harlow, the whole bit, Jimmy Klotz, Isabella Kagan. The effect is seen this way. When we have biocanon in the rumen from red clover, we do not remove the amino groups from protein as frequently, and there is more bypass protein. Bypass protein is a good thing in ruminants, and it boosts production. But the big payback is that this isoflavone, biocanon A, in red clover directly counteracts the vasoconstriction in tall fescue. I want to show you some ultrasound pictures of blood vessels that are constricted or relaxed with the presence of either fescue or isoflavones. On the left is a cross section showing the red, which is the artery, on an animal that is dosed with endophyte infected tall fescue, toxic tall fescue. And you can see the size of the artery cross section. If on the right, same animal, same type of animal in the study, where the isoflavone metabolites are causing this vasorelaxation, so we're getting more blood flow. And if you think back to the negative effects of tall fescue, endophyte infected tall fescue on cattle, it is vasoconstriction, which leads to heat stress and more time in the shade, more time in the pond, and less time grazing. Here is another set of data from that same USDA unit. The caudal artery is the artery that runs through the tailhead or the tail, and the luminal area, that's the cross section of the middle of the lumen of a blood vessel is the area across it, or the hollow space in it. So the cross section of the caudal arteries are represented here on 3 different forage systems. Bermuda grass, which is non-toxic, and the luminal area was 10.8 square millimeters. You mix red clover and toxic endophyte tall fescue, you got a luminal area of 9.2 millimeters squared. And if you look at toxic endophyte infected tall fescue and its effect, you had a lumen area of 5.4 millimeters squared. So we're having direct effect on the lumen or the vascular structure of cattle because of red clover. So adding clover is a great strategy to deal with tall fescue. Now the question often comes, does white clover and other types of clover have isoflavones? Yes, white clover does, but it's in less concentration than in red clover. So strategy number 2. Manage to minimize the negatives or manage to keep the plants leafy. And we do that by controlling seed heads. I will add right here that moderate use of nitrogen fertilizers is also a sound strategy, although it is not necessarily a leaf production strategy, although it does make that. Does make leaf appearance increase. Moderate use of nitrogen fertilizer is a good idea because the ergot alkaloids are nitrogen-containing compounds. Adding a lot of nitrogen to tall fescue will result in a boost in production of ergot or ergovaline and those toxic alkaloids. Tall fescue seed head management is important, and of course it's a good rationale because ergovaline concentrations are highest in the seed heads of tall fescue plants. And that's actually a misstatement. Ergovaline concentrations are not highest in the seed heads. They're actually highest, at least in most of our measurements, in the very base of the plant. The seed heads are quite toxic, but they lag behind that stem base. So make that correction if you're taking notes, and I will do the same on the lecture. Steers and geldings have been documented to selectively graze tall fescue seed heads. And it also occurs when ambient temperatures are higher. So this is, again, proof positive that cattle do not know, or livestock do not necessarily know, what is good for them. A lot of speculation about why they do that. The ergovaline compounds, the ergot alkaloids, are in the family of chemistry compounds that include LSD, that psychoactive hallucinogenic drug. So they're speculating that the cow or the cattle or the grazing animal will be getting some sort of a high because they are selectively grazing seed heads. The management strategies we need to control seed heads include mowing pastures timely after the elongation begins, higher stocking rates, which means as the stems are just beginning to be elevated, they're still green and soft, and the livestock will consume them, and also chemical suppression by a commercial product by the name that is marketed under chaparral. Chemical seed head suppression looks like this. The controls on the left. The chemical suppression is on the right. Chaparral at 2 ounces per acre, spray in late April or just before seed head elongation. And then you can see that you get a little bit of stem formation here in the right, but not like you do to the left. Again, another photograph showing the difference. The chemical seed head suppression from chaparral improves forage nutrition, the nutritive value, and steer average daily gain, but it also reduced forage availability. And if you look back to the picture before, a good bit of the yield of the first cutting of tall fescue, which includes the seed heads, is going to be that reproductive structure of tall fescue. When that's not produced, the yield is less. Your gains are higher, though, and I suspect your gain per acre is also going to remain higher on those pastures. Less occurrence of problems like pink eye from eye irritation and so on. So, in spite of the positives, farmer usage is limited. Cost is an issue. The fact that there's less yield is an issue, but probably more so at the root of the lack of adoption is the terrain. A good bit of our tall fescue fields are very hilly and not conducive to spraying a lot of herbicides. So back to a graph we've seen before, that the stem bases are the most toxic, the seed heads and the tops of the plants are the middle or moderately toxic, and the leaves are the least toxic part of the plants. So leaves are less toxic, stem heads and stem bases, seed heads and stem bases are the most toxic. All right, strategy number 3 is avoidance during problem times of the year. And while I don't elaborate on this here, what are the problem times of the year? Well, for breeding cattle, and a lot of times for our fall calving cows, for our spring calving cows, the breeding period starts around May 20. So therefore, having different pastures to go to from in May for a spring calving beef cattle herd is going to be a good avoidance strategy. For thoroughbred mares, who typically are bred to foal in either starting in mid-January and on, then you're going to want to have fields they can be on that are free of the toxicity in the from September on throughout that third trimester, whenever that occurs. So we're going to be looking for alternative forages, such as most of the time we're thinking of summer alternatives. And this is actually a Ballard County farm in western Kentucky that raises Herefords, and for several generations of cattle, and they've improved the genetics, and they are marketing grass-fed beef. And they will plant corn and strip graze the corn with the electric fence that you see in the foreground. And this, of course, is a one-shot grazing crop, but it will put remarkable gains on cattle. In this case, you've got cows and calves. Grazing alfalfa is an option. Of course, we've mentioned grazing red clover, warm season grasses, native warm seasons, or introduced species like Bermuda grass is an option. You may recognize this picture, or at least you've seen this farm before. This is the Eden Shale Farm in Owen County, Kentucky, in northern Kentucky. This is a little area at the end of one of its the ridges that's primarily tall fescue throughout the rest of the ridge, but they've established some switchgrass here to provide a break from being on toxic tall fescue. Summer annual grasses, such as in this case sorghum Sudans. This happens to be a brown midrib variety of sorghum Sudan grass. These are excellent alternatives to tall fescue. And if you move on to the fourth one, which is replacement, tall fescue in certain cases is I will say it this way: the economics of the benefits and the production that you can get from something else will then justify complete replacement of that tall fescue. But I would say that the number or the order of adoption of management strategies that you should take: start with clover. Number 2, manage it to keep it leafy. Number 3, avoid it during the most problematic times. But replacement is an option when the opportunity is there for payback over a number of years. So what are you going to replace it with? You can go with other cool season grasses, endophyte-free tall fescues, the novel endophyte infected tall fescue. Of course, we call those novel endophytes, friendly endophytes, non-toxic endophytes. Varieties that are currently available for non-toxic or friendly endophyte tall fescues would be Max Q, Texoma, Bar Optima, and Lacefield. And as you will know, and we'll talk about again in the variety section, if you find a novel endophyte tall fescue, you'll have 2 names associated with it. The first one is the genetics of the grass. The second one is going to represent the genetics of the endophyte, because each DNA is separate and important, and each one of these has a different commercial endophyte in them. Let's take a look specifically with dealing with toxic tall fescue in horses. And your strategy is primarily, in fact, it's almost the only strategy, but I should say the major strategy. It's avoiding TE, toxic endophyte, tall fescue in the last trimester of pregnancy. So we're talking about pregnant mares. I was doing a little searching this morning and asking about, are there measurable effects of the toxic endophyte of tall fescue on yearlings and other classes of horses? And the answer is, although we can measure a physiological response like vasoconstriction, there are no measurable performance differences that have been found to date. You can dilute the effects of tall fescue with with hay, with clover in a pasture, but because the horse is so sensitive, the pregnant mare is so sensitive to toxic endophyte tall fescue, the best and the only strategy for most cases is replacement of the tall fescue. And then you would answer with what, and I'll just leave that as an open question, because you need something that is tough like tall fescue, that provides a long grazing season, but that's not as easy to come up with as it sounds. I want to mention domperidone at this point. Domperidone is not a forage, it's actually a pharmaceutical product labeled for use in horses that directly alleviates fescue toxicosis in pregnant mares. Now you might think, oh my goodness, that's great, we've got a total solution. Well, and in fact you do, but if you have to invoke this solution, it is, as I understand it, a daily treatment, and it's expensive. So domperidone, while it's available, is certainly not practical in most cases. And as we get towards the end of the lecture for today, I want to talk a little bit about what we are doing with novel endophyte tall fescues in the way of forage demonstrations. I mentioned earlier that the only way to know if a forage or fescue is going to live for 25 years is to plant it and come back and look at it 25 years later. So we continue to plant novel endophyte tall fescue demonstrations over time that we let the farmer manage and use, just like the rest of their fields, and to see how it responds and how it lives and survives. This happens to be John Thomas, the farmer, on the right, Madison Sears, the agent, on the left. That is Texoma tall fescue in the spring following a fall establishment. A great stand of tall fescue. So summarizing what we've talked about today in the second half, if we're going to make fescue work, we've got to understand it, we've got to manage the tall fescue toxic effect. We do it by managing it by diluting, and I've got those out of order there just to keep you on your toes. The first strategy is dilute it with clover. We call that renovation. The next one is to manage it so it's leafy, then avoid it during problem times, and finally replacement. And with that, I'll draw this part of the class to a close. And until I see you next time, happy foraging.